Humans are good at some things, AI others. Human in the loop is how you get the best of both worlds. If your agent needs human approval or feedback before taking the next step, the human in the loop approach enables it to pause execution and await input from the user before proceeding. Yes, asking for approval before taking a sensitive or customer-facing action is a no-brainer. The human in the loop approach can also facilitate collaboration between the agent and the human, whereby the user can correct mistakes or provide feedback and context the agent doesn't have, ultimately to get the best and most efficient possible outcome. My name's Alex, and in this video, you'll learn how to implement single-turn human-in-the-loop interactions in Mastra, a TypeScript framework for building AI agents. Now, human-in-the-loop can look quite different depending on what it is exactly you're building. That's why in this video, we're focusing on the fundamentals. Together, we're going to look at two increasingly complex examples that illustrate how the Mastra suspend function works and how you can use it to implement common human-in-the-loop patterns. Let me introduce you to this customer support workflow. The idea is that when a user submits a query to your system, you can run this workflow to generate an answer automatically using an LLM before responding directly. In this particular case, I'm not really responding, I'm just logging the value to the console, but you can maybe imagine how we could respond in a chat interface or maybe reply via email. What does this have to do with human in the loop? Well, right now, nothing. I want to show you the code for this very simple workflow to set the foundation, and then we're going to update it together to introduce an additional step, which is going to ask the user, probably some support agent in this case, to approve the message before responding to the customer. Let's walk through it together, and you can also find the code on GitHub if you want to peruse it in your own time or maybe run the code locally. Whenever you're trying to understand a new workflow created in Mastra, you should definitely start by looking at the create workflow function. This is like the recipe or the blueprint for the workflow, and it makes it quite easy to trace at a high level what is happening. In this case, we accept a query as the input. We don't have a specific output because this workflow has a side effect, right? Sometimes a workflow will return a value for you to then process, but in this case, the most important thing for the workflow to do is that side effect of responding. The first step is to generate an answer. Once we have the answer, we move on to the next step, which is to respond. Let's look at each of these steps in a bit more detail. The generate answer function takes the given query and returns an answer based on the text generated by the LLM. How do we call the LLM? We do that by calling into this customer support agent and asking it to answer the customer query, which we then pass before returning to the next step. I totally appreciate that when we call into a separate file like this, especially one that is an agent, you might think it's doing something kind of interesting or fancy, but in this case, it's a very minimal agent. It's really a thin wrapper enabling us to prompt GPT-4o Mini with that query and access the result text, which we then return as the answer. What do we do with that answer? Well, again, in this case, just log it to the console, but you can perhaps imagine how this could integrate with your system more broadly. Let's introduce an additional step to ask the user for approval before responding to the user. Again, we'll ask a general product query, and the generate answer step runs to output a message. But rather than respond directly like we saw before, this step called ask user for answer pauses the execution of the workflow. And then on the right-hand side of the playground here, you can see that we have the option to resume the workflow. And we also have this approved checkbox. If we resume the workflow, but we do not approve the message, it throws an error. Let's run the workflow from the top again, and this time approve the message. As you can see, it responds to the user like you might expect. This is an example of a human in the loop interaction. Let's see how it works in the code. It's this ask user for approval step that's new and needs a closer inspection. So let's open that up right here. The star of the show when it comes to human in the loop interaction with Mastra is this suspend function. It's calling suspend like this that puts the step in this paused or suspended state. Suspend also has the effect of asking the user to provide some additional data required to resume execution of the step. In this case, it's the approved Boolean as defined by the resume schema. When the step is resumed, we can access the value of the resume schema via this resume data argument. So what's happening here? First of all, we check to see if resume data is present or not. If it is not present, that means this step is executing from the beginning. It is not being resumed. And if we're executing this step from the beginning, actually what we want to do is immediately halt and suspend, hold our horses, and wait for the user to provide an input before proceeding. So on line 4 here, we immediately call suspend, and we use return like this to exit the function early as not to run any more code. We're done running the execute function until the user gives us some more data to resume with. When the user resumes, for example, by ticking approved like this, the step executes from the very top again. This time, resume data will be present, which means we'll skip over this block, and we can start to do some final logic. In this case, we check to see if the message was approved. If it was not, we throw an error, and it's that error that causes the playground to show us that big red angry box indicating that there is an error and the workflow execution ends. You don't always want to throw an error like this. That might be a little bit aggressive. And so an alternative is to call the bail function. This ends the workflow execution, but without an error. So while it doesn't throw or anything, it doesn't actually call the respond step either, which is pretty much the behavior you expect. It's just a bit gentler. If we get to the bottom of the execute function, that means that the message was approved and we can return the output schema, which is the answer. And this output schema is then passed to the final step called respond, which does what it says on the tin. And there you have it. That's your first example of a human in the loop interaction using Mastra. Before we move on to a slightly more complex example, I just want to point out something quite fundamental, which is that when you pause a workflow in the Mastra playground, you might get the impression that you need to take an action right away. You've got this timer counting up and we're prompted right away to resume. But understandably, when you implement this workflow into your own system, you'll be accessing it via function calls, and your user may not be ready to approve the input right away. The really cool thing about Mastra is that the state of the workflow is represented in a JSON structure, either in memory or a database depending on your configuration. And because it's persisted, well, check this out. It's currently prompting me for an answer. But if I reload the page, you might think, oh, I've lost that workflow. But no, in the runs tab and the most recent run, we can then pick up where we left off in order to, in this case, approve the message and resume. I'm not going to go too much into detail about how to run workflows in your own code base because this video is very much focused on the concepts and fundamentals, but I think it's really important to know that you can resume a workflow after a minute, after an hour, even after days, right? For example, if the support agent goes offline in the evening and then comes back in the morning, they can resume the workflow in order to respond to queries then. It would be no problem. I love this example because it focuses on the primitives that we are going to continue to build on as these examples get progressively more complex. But realistically, do we need to approve every single message generated by the LLM? I don't think so. I don't think that's an efficient use of time because actually the model is going to get it right a lot of times. Let's explore how we can make this same idea more sophisticated. Okay, how does this look for more sophisticated? There's definitely more going on, right? But don't worry, I'm going to make it really simple to understand. This is an evolution of the customer support workflow you saw before, but whereas before it would ask the user for approval regardless of what they asked, this updated workflow introduces the idea of branching so that if the incoming query is categorized as a general inquiry, the workflow will generate an answer and respond immediately without the need for human approval. Comparatively, if the incoming query is categorized as an order inquiry, maybe the user wants to know, like, where is my order? How long will it take? Something like that. Well, the model doesn't really have knowledge of that, and we haven't built this system in such a way it can access that information with RAG. And so we're going to ask the user to answer the support query manually. Let's see this in action real quick, and then we'll look at the code to understand how it works. So let me ask the same question about a general product question. As you can see, the categorize query step categorizes the incoming message as a general message. According to this branch, it generates the answer and responds. If we run the execution from the top and we ask, where is order 99, for example, this time the categorize query step determines it's an order inquiry, and therefore it branches this way to ask user for answer. This step suspends the workflow and prompts the user, me in this case, to provide an answer manually freehand. This is very similar, but also a little bit different from what we saw before. Last time we were asking the user to approve a generated message. In this case, we're asking them to provide the answer manually, maybe after looking at the order in a separate system. I just wanted to show how you can use different data types when resuming steps. Listen, I don't know where your order is, sorry. So I respond, and just like before, this response step is a little bit contrived in so much as it doesn't actually respond, but writes to the console. But you can totally imagine how this might reply to an email or put a new message in a chat interface, for example. Let's take a closer look at how this works. As a reminder, this workflow is an evolution of the customer support workflow you saw in the previous step, and so some of the code should look quite familiar. The unique part is really this categorization and branching process. So when we kick off the workflow with the customer support query, we first categorize the query by calling this categorize query step. We'll look at this in more detail in a second, but just note how the output is a category. And it's that same output that we reference when branching. If it's a general inquiry, we generate the answer directly by calling the generate answer step. If it's an order inquiry, we're going to suspend and await user inputs using the ask user for answer step. Only one of these steps will run because only one of these conditions can be true. However, they both ultimately have the same goal. They just do it in different ways. Both of these steps aim to output a message, which we should then respond to the user with. And because this response step is expecting a message, it knows what to do. So whatever path the execution takes through the graph, it's ultimately going to respond to the user. This pattern whereby we categorize an input before deciding what to do is extremely relevant to human-in-the-loop interactions because we do not want to have to approve every single action or every single message. We want to harness as much power as possible from the LLM in order to produce autonomous agentic workflows. We only really want to give inputs when it's necessary, for example, to give feedback or refine something, such as a response in this case, or to approve or authorize a sensitive action. A really cool pattern that's gaining traction in production systems is actually using an agent to categorize an incoming input in order to determine what to do next. This is a rather simple example, but I've seen certain agents which can produce a score and based on the score branch and decide what to do next. Here, we're using a query evaluator agent, which again sounds kind of cool, but it's mostly a simple wrapper around GPT-4o Mini. The interesting part here is how we are coercing the model to return the category like so. Rather than try and parse this string or something, we're leveraging Mastra's structured output feature in order to define the expected output format. We're letting the agent know that we would like it to return an object with a category property, and we want that category property to match the type of the category schema enumeration here. This step then returns the category like so, as well as the input query, such that we can access it in subsequent steps. There's no need to look at the generate answer code because it's the same as the previous step. If it is a order inquiry, we call the ask user for answer step. This is again a little bit different from before. Before we were asking for approval. This time we're asking for the user to actually provide the answer. And I think this is interesting because human in the loop, we often think about authorization, authorizing a sensitive action, but it's also perfectly appropriate to suspend in order to ask a clarifying question or leverage the expert context the user has before taking a next step. The mechanism here by which we suspend is more or less identical. However, if there's no resume data, that means we're running this step from the beginning and we want to halt and suspend immediately because we can't really do anything until we get the answer from the user in this case. when the step is resumed, Mastra will execute the function from the top again, skip this block because resumed data is present, and return the answer, which is ultimately consumed by the final step, which is to respond. The only extra thing I can make clear here, I think, is that when you see suspend called like this, it might be tempting to think that it's similar to awaiting or calling promise.then or something like that. That's very much a JavaScript concept, right, for the JavaScript runtime engine. In this case, it's actually Mastra that is the execution engine. And when you return, the function finishes. It doesn't really run any more code in this case. However, Mastra will pick up where it left off and run this execute function from top to bottom again when the step is resumed. So yeah, I think this is a bit more of a realistic example, right? Because it shows how to harness the power of an LLM when possible and then defer to the user when necessary. I think by showing how different steps can be composed in different ways, maybe your mind's starting to tick a little bit with new ideas, such as maybe the user asks for a refund. Well, that's definitely something you'd like a user with knowledge and good judgment to approve before doing, as opposed to letting the agent rip. You could absolutely incorporate that into a workflow like this using Mastra. Thank you for watching. That was your introduction to single-turn human-in-the-loop via Mastra. We think human-in-the-loop is an essential pattern for building highly agentic and reliable agents. It's therefore important that we provide a mechanism flexible enough to pause and resume interactions at the same time. And that's where the suspend function comes into play. If you have any concerns or questions or requests about suspend or human in the loop with Mastra generally, write them here on YouTube and we'll get back to you. We're making a lot more videos here on the Mastra channel, and who knows, maybe your question or comment becomes a video. By the way, in an upcoming video, I'll teach you how to implement multi-turn human in the loop interactions with Mastra. If that's already live, there'll be a link on the screen. Otherwise, subscribe as not to miss it. I've been Alex Booker with Mastra. Thank you again for watching.